OPcache is one of the most important levers for optimal PHP performance, and let's be honest, you should get this right because it's a basic building block of PHP performance and it's just a few settings to tune. In this video, I'm going to show you everything you need to know about OPcache performance and close with a few hidden gems of OPcache changes in PHP 8.5 last year. Even if you have worked with OPcache for years, there should be something new for you in this video. Moin, I'm Benjamin, and in my work I've focused on PHP performance topics for the last 10 years, helping thousands of developers along the way. Before we start, I would like to ask you to subscribe to this channel if you're interested in everything related to PHP performance. Why do you even need OPcache? It's simple. PHP compiles every script it runs into an intermediate bytecode, which is then executed by the virtual machine of PHP. So it's a two-step approach. The first step, compiling from PHP code to bytecode, can be completely cached. And because the step may take several hundreds of milliseconds for every request, it absolutely makes sense to cache it. In PHP 5.5, OPcache was introduced, so that's already like a long time ago, about 15 years. It was included in PHP Core, and before that there were competing extensions. One was called APC, and OPcache was a paid product by the Zen company. As none of these extensions were included in the core developers had no way and incentive to make them work during the release. And that usually led to a few months of incompatibilities, crashes, and you needed to wait a little time to get everything working and before it was stable. With OPcache in PHP Core and enabled by default in 8.5, this is a thing of the past for a long time now. But how do you validate that OPcache works? So there are a few default ini settings. If the extension is loaded, then it's enabled by default, so you don't have to care about that. On the CLI we will see later there's an additional setting. So if the extension OPcache is installed and activated, loaded, then it should be enabled by default. You can verify this easily through the PHP info output. You will see a Zen OPcache section. It states that OPcache caching is up and running. It differentiates between different features, we'll see that later, and it also provides some statistics of its efficiency. There's also a function that you can call OPcache get status. It's only available if the extension is actually loaded. So if you call it in a different scenario, the PHP process will crash. But this script also gives you an output that you can use to evaluate if OPcache is not only loaded but also enabled and configured correctly. You find a way to access the different statistics to see if OPcache is running efficiently. But what does running efficiently mean? There's essentially three settings that we look at that control like most of the performance gains around OPcache. The first one is OPcache memory consumption, the second one OPcache interned strings buffer, and the third one is called OPcache max accelerated files. If you configure only these three variables correctly, they make up to 95% of the gains that you can make with OPcache possible. The other 5% are through different other changes. Let's start with OPcache memory consumption. So this variable defines the size of the shared memory storage used by OPcache in megabytes. So as I explained before, OPcache caches the step from PHP code to bytecode. And if you're running PHP inside Apache mod.php or PHP FPM or FrankenPHP, for example, you will have many different requests running in parallel. And OPcache shares this compilation step between all these different workers that are processing requests. So for one process of PHP, there is one OPcache. So if we declare 128 megabytes, which is the default for the OPcache memory consumption, then it will be used for all the PHP scripts that are compiled in this process and all its child processes that are handling workers. How do we find out if this variable is not configured correctly? Let's look at the output of OPcache get status. We find a section memory usage, and in a case where it's not efficient, we see that used memory is very high and free memory is very low. If free memory is very low or zero, that means that it's very likely that there is additional scripts that need to be compiled that need additional memory that couldn't be compiled because of this. And we can find out with the OPcache statistics here, looking at hits and then specifically at misses, meaning there are scripts being compiled that are not, or loaded, that are not in OPcache. If this number is higher, this means there are some scripts that are not in OPcache. We can see the hit rate here, 98%. So that's not optimal. It should be like 99.999% or 100% of scripts being cached. You can also see this in Tideways, which collects this information across all your servers for an application where we can see OPcache is running low on memory and it suggests a higher value to configure. So this is the same information, just in a central location across servers. For an application running a modern framework like Symfony, Laravel, or applications built on top like Shopware and WordPress and Magento, I really recommend increasing this memory consumption from the default. So the default is 128 to, for example, 256. For an application that has this configured correctly, you'll see that the free memory always has some breathing room. So there's a few percentage or like even a 10-20% of free memory available at all times. The second variable we need to look at is OPcache interned strings buffer. This is set to 8 megabytes default. And the first thing that we need to explain is what are interned strings and what is this buffering. So an interned string in its simplest way is just a hard-coded string in any of your PHP scripts. So let's say you have your own email address configured in a variable to send an email to, then this string can be interned because it's in the PHP script. But also all names of all symbols, so classes, functions, constants, method names, all these are hard-coded strings that can be compiled to an interned string. And an interned string means that OPcache stores the value or sort of like the characters of the string in shared memory. And then these shared memory strings are reused across all scripts that are run in parallel. So if you don't have this buffer and set it to 0, this means that every request needs to allocate the memory for all these symbol names, all these variable names over and over again. And so it's a lot of wasted memory here by reusing the same variables. How can you find out if the interned strings buffer is too low? Again, we look at the configuration at the output of OPcache get status, or the PHP info output also has this. If we see interned strings free memory going towards 0 or close to 0, here we see also free memory, then this means that there is most likely an improvement possible by increasing this from 8 megabytes to a higher number. And I always recommend to 32 megabytes, especially for modern frameworks. And I recently found out that I thought that 32 was actually megabytes was the highest number you can set this to, but you can increase it much further. The only constraint is that the interned string buffer size is a share of the total memory consumption. So if we look at the interned string buffer being 8 megabytes, then it's a share of the memory consumption. If we increase that to 256, that means 8 of those megabytes are for the interned strings and the rest is for the compilation of scripts in general. And if we increase this to 32 megabytes, it is essential that you increase the memory consumption from 128 to a higher number. But if you need to increase the interned string buffer to 64, which is sometimes the case for large applications, then you also need to increase the memory consumption, maybe even more. So these two variables sort of are linked together. Again, you can also find information about this in Tideways, where it says OPcache is running low on intern strings memory and then makes the recommendation to increase this. And if you change that variable and everything is fine, then Tideways will show this to be not a problem anymore. In the output of OPcache get status, you will also see intern strings usage. You have the buffer size and the amount of memory used, and the free memory again here is a number higher than 0. So you see we have like 114,000 of strings interned, and we still have a lot of free memory available. The third variable we want to look at is OPcache max accelerated files. This one defaults to 10,000 files. And here again, for modern frameworks like Symfony, Laravel, Magento, Shopware, this number is most likely too small. And there's actually no harm to just increasing this to 100,000. And then you most likely don't have a problem unless you're using PHP files for caching and you have like a very large vendor directory that is used excessively. Then maybe you need to increase it even higher. Again, you can look at the PHP info output for OPcache, specifically for cached scripts, which translate to a concept called cached keys internally. So it's, in this case, almost double the size. If the cached keys number here is smaller than the max keys, then you're fine. But if they are close to each other, it makes sense to increase the number of accelerated files to automatically increase the number of cached keys. So these concepts are linked internally in OPcache. The sort of correlation is a little bit tricky and not important to know. It's just important to know cached keys needs to be smaller than max keys. So this gives you 90 to 95% of the OPcache optimization possibilities if you have set these three variables correctly. That means all the scripts are on OPcache, they are loaded from OPcache, the compilation step is never triggered, memory is shared between the requests with respect to strings, and reduced memory usage also means that the scripts are running faster because they don't need to allocate memory, and this makes PHP run extremely fast. However, there's also a few hidden gems in OPcache where you can squeeze even more performance out of it. And I want to show you some of these and explain how they work and if they make sense to you. Let's look at a more advanced OPcache configuration where we already set the memory consumption to 256 megabytes, accelerated files to 100,000 and increased the intern strings buffer to 32 megabytes. The next thing that you can look at is the setting OPcache validate timestamps. And what this does is, whenever a PHP script runs, it checks if the current timestamp of the script, the modification timestamp, is maybe more recent than the script that is inside OPcache itself. And if that's the case, it recompiles this. For this check to be possible, it needs to look at the modification time of a script for every script that is used during a request. And accessing this information takes a little bit of time. And if you know that your code never changes, so you never deploy over an existing application, you never change code at runtime, then you can just switch this to 0, and then the code is always loaded from the OPcache after being compiled once, and it will never be reloaded from disk. And this will improve performance by 1 to 3% or something like that, depending on the type of application. The second thing that you can look at is OPcache preloading. Preloading is something I've discussed in a previous video, and you can find the link in the description. It works like this. While OPcache compiles a script to bytecode and caches this information, it still needs to go through the autoloading stack and potentially call require once to load a file, and then based on this file, the class's functions in OPcache are copied into the memory. If you want to skip this autoloading and compiling step, you can use preloading, and preloading compiles the scripts at startup of PHP, FPM. It puts them into shared memory already, all the classes and functions, and on every request they are available automatically at the beginning. And this saves another few milliseconds, depending on if your scripts are running very fast, like around 100 milliseconds or less. You already optimize a lot of performance, then you can squeeze another maybe 5%, 10% out of your script here. If you want to learn the details about OPcache preloading, please look at my specific video about this on this channel. Another variable that you can see commonly that we should discuss is OPcache enable CLI. And I want to make a video about this because it has a lot of information that we need to look at. By default, OPcache is not enabled on the CLI for different reasons, specifically because every cron job, every worker script running on the CLI is its own process. So if it's using and compiling scripts, then this will not be reused across a different script. And this sort of processing step is wasted. And in many cases, it doesn't make sense to use OPcache on the CLI because of that. For long-running workers, it might make sense because then the script will run faster, and because the long-running script just like takes a lot of time, it might make sense to do that. However, this requires additional memory, and if you are running a lot of workers or a lot of cron jobs in parallel, this means you are closer to the maximum memory of the server, and you need to think about this problem and handle this accordingly. The last configuration settings block I want to discuss here is related to the file cache that OPcache provides. So before we talked about OPcache being a memory cache that contains the bytecode for every script, you can also instruct OPcache to save this bytecode on disk. And this is called the file cache. And for some specific scenarios in the web context, this made a lot of sense. You can see here I'm mentioning Brev, which is a runtime for PHP on AWS Lambda. So there's a blog post by Mathieu, the author of Brev, about optimizing the cold start time of Laravel on AWS Lambda. What is a cold start? So if you run a PHP script for the very first time, it needs to be compiled to bytecode. And this hurts the first person accessing an application. And if you don't restart PHP FPM a lot of times, then maybe that's fine and you don't need to handle this. But in case of an architecture running on AWS Lambda, for example, you have containers that are stopped after a certain amount of time, and then they are started when a new user comes in. So the likelihood of users running into cold starts, so running against a PHP process that has never run the script before, is higher. And in that case, you might want to already warm the cache before. This blog post from Mathieu explains how he is improving this. And he shows, let me show you like a little script where he sort of declares a number of directories he wants to pre-compile, then iterates over all the files and uses a function called OPcache compile file to like compile this script. And if you configure PHP with the file cache and using this setting, then the OPcache compile file function will produce a cache file into this cache directory here for every script. And then if the memory cache of OPcache is empty, it will look for the file cache. Specifically for his example, there are also new variables here. One of them is available only in PHP 8.5, which is the file cache read-only variable. So this one is new. It allows you to use the file cache on a disk that is read-only. So in case where you compile a container on a write volume, you sort of generate all the file cache representations of every PHP script that you need, and then you write the container to an image, you ship the image to the production system, and on the production system the volume is read-only. Then you need to set this setting, which is only available with PHP 8.5. You could even use file cache only, but this doesn't make sense in the web context. It might make sense on the CLI. And with this kind of settings, you can avoid the cold startup time in PHP, FPM, or Apache. The benefit of this is small. While Mathieu says that cold starts were 40% faster, he also says that from his numbers, cold starts are very rare, only about 0.3% of all invocations. So it's not that it happens quite a lot of time. And this is a performance improvement that might help you in a specific situation, but a lot of people will not benefit from this additional overhead and all the maintenance getting this set up and running. If we talk about OPcache, then we should also talk about the JIT, because the JIT is part of OPcache. However, I don't really feel comfortable suggesting you to use the JIT. From anecdotal evidence, it's not clear that it improves PHP scripts at all, both for scripts running in the web context and the CLI contexts, even for very heavy processing scripts that only do like a little bit of I/O, it seems you cannot really see a big difference. So JIT probably needs some additional things to be better. I can't really tell you how. I can't tell you what are the levers for it being efficient or not. It needs to be addressed for like your use case, and you should try it out yourself. So before we close, I think we saw that enabling OPcache just makes a huge difference, and we saw different ways of configuring it. However, one thing that might accidentally happen in your case is that OPcache is not even enabled. And there's a specific scenario and also specific configuration problems where you seem to think that OPcache is available, but it's not, or it's the configuration changes you make are not addressed. So first, in Docker with PHP 8.4 and earlier, you specifically needed to install the OPcache extension. It was not used by default in the official PHP images. Without this line in your Docker file, OPcache is not even installed, and you don't benefit from the performance gains. The second problem that you might have is that you are changing the OPcache configuration settings in PHP's FPM configuration file through the PHP admin value directive. If you do that, then if you look at the PHP info output, then you see the changed it. So if you see 256 here, OPcache will show this information. However, because OPcache is such a central extension being loaded, the memory is actually already allocated at that point, and PHP FPM does not have an influence on this setting anymore. So even if we see this here, PHP info shows 256, it still only allocated the default memory of 128. You have to set this inside the PHP ini file, because only this file is read at the startup and then leads to the allocation of the memory. When PHP FPM comes into play, it comes to a specific pool and reads the pool information that is already too late, and changing it here doesn't take any effect. With PHP 8.5 you will get a warning about this, and also it doesn't show the changed value in the PHP info, so it's easier to find this kind of problem. Before you were kind of at loss. You would see the statistics showing keys not being allocated, memory overrun, but you changed the values again and again and nothing changed, and this is sort of the problem why this happens. So I hope you have learned something new. OPcache is really a wide topic. It provides you with a lot of benefits of PHP performance, and there's a few things added in the last version that allows you to squeeze a little bit more out in special scenarios. And there's also a lot of certain information that is not very well known about the relationship between memory consumption and intern strings buffer. Hopefully you learned something new. If not, please complain in the comments. Maybe you can give me an idea for something more to talk about. I'm always happy hearing from you. If you like this video and want to see more, please subscribe to this channel or subscribe to the newsletter. The link is in the description. Bye!